Okay, so in this video, I'm going to finish the production scheduling problem. We're going to enter the data into Excel and solve the problem. So let's write down all the decision variables we had. We had 8 decision variables. We had SR1, SO1, SR2, SO2, DR1, DO1, DR2, DO2. So these are decision variables, and obviously we have left hand side and the right hand side. And slightly bigger. There you go. Okay, first are the decision variables. So these are our 8 decision variables right here. As usual, I'm going to color them. And the objective. Oh wait, I completely forgot the two. We have the inventory constraints. We have inventory decision variables SI and DI. Let me not forget that. Make it slightly smaller. Okay. So these are the 10 decision variables, not the 8. And the objective is it's $10 here, $15 here, $10 here, $15 here, $16 here, $24 here, $16 here, $24 here, and $2 and $2. So this is the total cost of manufacture and inventory. Right, and you'll be minimizing the total cost. That's the objective. Let's try the constraints. Right, so there are 8 constraints. So first, let's begin with inventory constraints. Or let's demand constraints. So I'm going to have demand regular 1, demand regular 2, then demand deluxe 1. And demand deluxe 2. So those are the constraints that we're going to have. So if you look at the 4 constraints, so these are the constraints for these are standard. Yeah, you know what, I was mixing them up. So standard and deluxe. Right, let's write the standard constraint. The standard constraint is the total amount of standard wheels that you make in the first month. Now, yeah, so I forget to do this. As usual, I'm going to rewrite the first 2 constraints because I want to move all my decision variables to the left hand side. So I'm going to write this as SR1 plus SO1 minus SI equal to 1000. Right? Let's make this just a little bit. And make that bigger. Everything fits nice and easy. Right. Similarly, we'll say DR1 plus DO1, right, minus DI equal to 1250. So that's how I'm going to rewrite the first 2 constraints, and that's how I'm going to put them here. So SR1 plus SO1 minus SI equal to 1000. Similarly, DR1 plus DO1 minus DI. Wait a second. Yeah, made that mistake. Okay. Yep. So that we have now, let's write everything here. So it's DR1 plus DO1 minus DI is equal to 1250. Right. Now the demand for the second month. So you're saying SR2 plus SO2 plus SI is greater than or equal to 800. It's a standard for the second month. Then you have dr2 plus do2 plus di is greater than or equal to 1500. Let's make sure I got the right numbers. 800 then 1500. So dr2 plus do2 plus di, right? Now let's write the time constraints. So regular time 1 and regular time 2, similarly so regular time 1 and regular time 2, and then overtime 1 and overtime 2. So that's 4 constraints. Let's write the regular time constraints first. So it's 0.5. I think, yeah, 0.5 times 0.6 is less than or equal to 1000. Total amount of regular time available. No. So you're writing the regular time constraints first. So it's going to be 0.5 here, 0.6 here is less than or equal to 1000. So the 2 regular time constraints over the 2 months. Similarly, 2 overtime constraints. Less than or equal to 500 hours. Oops. Similarly, less than or equal to 500 hours, right? Okay, so you're saying 0.5 times SO2 plus 0.6. Yep, 0.5 times SO2 plus 0.6 times DO2 has to be less than or equal to 500 hours. Similarly, first overtime 0.5 times SO1, 0.6 times DO1 less than 500. 0.5 times SR2 plus 0.6 times DR2 has to be less than 1000. Similarly, regular time in the first month 0.5 times SR1, 0.6 times DR is less than 1000. All right. So once we have all the decision, all the data in, let's write the sum product function. That's the sum product formula to actually tell Excel that this is what our left side of the constraints are doing. Objective coefficients don't have the dollar signs, the decision variables do. Right? So I have all the sum product formulas in. Let's put it into the solver and solve it. For the solver, the objective is to minimize the total cost. Minimize total cost. The decision variables are all of the decision variables here. We can change this to LP and add our constraints. So I'm going to write the equal to constraints first. So the left hand side of the equal to constraints should be equal to the right hand side of the equal to constraints. Click add. Then the greater than or equal to constraints, or 2 greater, the left hand side of 2 greater than or equal to constraints has to be greater than or equal to the right hand side of the 2 greater than or equal to constraints. And finally, the 4 less than or equal to constraints have to be less than or equal to the 4 less than or equal to constraints. L10 to L13 less than N10 to N13, right? So 4 less than or equal to constraints, 2 equal to constraints, and 2 greater than or equal to constraints are done. So we're going to click on solve and solve this problem. Wait a couple of seconds. And there you go. So that's the final solution. The final solution says it's going to cost us 67,500. We can't do this for less than 67,500. And this is the final solution. That is, you make 500 standard wheels in the first month in regular time, 500 in overtime, 200 standard wheels in the first month in regular time, 600 in overtime, 1250 deluxe wheels in the first month in regular time, nothing in overtime, and 1500 deluxe wheels in regular time, nothing in overtime. So you basically are only using overtime for standard wheels, and obviously that makes sense because regular deluxe wheels is so much more expensive to pay overtime for the deluxe wheels, right? And that's the final solution. It can cost you 67,500 for the manufacture plus inventory and cost, and it's not gonna you cannot do this for less. As you notice, you're not carrying any inventory over. So you had the potential option for carrying inventory over, and you're not doing that, right? Okay. So this is the solution for the production scheduling problem. All right. Take care.